Is this thing on? Testing. Are we live? Are we back? You best bet we're back. Let's go CNC port some cylinder heads. We got a lot to catch up on. Yeah. CNC porting. Of course, I'm very passionate about that. I like any and all things CNC, whether that be 2-axis, 3-axis, 4-axis, 5-axis, 6-axis, or 9-axis. I don't care. The more axes, the merrier. Today, we're going to be playing with 5 in our UMC 750 SSP from Haas. We are going to be CNC porting a LT4 head. This is going to be the first time I have ran this program on an LT4 head. We have ran LT1s in the past, but we want to make sure that what we're running in the LT4 corroborates our port in the LT1. If you don't know, those heads have a different chamber design. Overall, the architecture is the same, aside from some minor casting differences, so I don't really know what to expect. I may have to completely back up and punt and do a separate LT4 program. That's what we want to know today. I've got a test head sitting beside me that I don't care if I scrap. Of course, we never scrap anything around here. I don't know a CNC machinist that does. We're going to put it in the machine. I'm going to show you what I do in CAD, what I do in CAM, and what we're doing in the CNC machine to make this thing come to fruition. So strap in, hang on, and hold tight because we're about to dive in. Let's go to the machine. Cool. We are sitting at the computer right now. I'm going to walk you through my CAM, computer-aided machining programming process to do, well, basically any cylinder head porting. It's relatively the same process from start to finish. I really like to tell people it looks incredibly difficult, but in all actuality, it is incredibly simple. We program in Mastercam utilizing the Port Expert toolpath. I kid you not, it is as simple as selecting a surface, and it does all the hard work for you. There's no voodoo magic in it. It's easy. You pay for it, but it's easy. So, as you can see here, we're set up at the computer. I like to break all of my machining toolpaths into individual faces. So as you can look over here, I've got this broken into intake face, deck side, exhaust face, and chambers if we have them. So I'll go ahead and highlight our chamber toolpath group. And as you can see, that is a not LT4 chamber. That is the LT1 chamber. I go ahead and touch it, and the reason I'm doing that is just to ensure all chamber depths are the same. GM does a pretty good job of getting them there. But in and around this area, most of you who know what we're looking at, there is a funny looking flat boss right there. So that is utilized as the W-axis datum for GM to probe each individual face and set chamber depths. It takes the delta difference between them and just skews however to get the head similar in combustion chamber size. That's how that works. So we're not going to be running that. The only reason I do that is just to take that nice little hump out and get a nice smooth flowing chamber. These heads were never meant to be introducing fuel in through the port anyway, which is kind of the downside of this head and why I think the LS is right now a better option. If you're using a factory casting, port has a lot of port speed. This thing is noisy on the bench, and there's not really a lot you can do to it because the way that I would correct it, you find the water jacket, so can't really correct it. But the head was never intended for that from the OEM. This is a direct injection head. It's meant to do what it's meant to do. It's a good head functioning for that, but it's a trade-off. So that's my own personal opinions. Is what it is. So what we are going to do, we are going to post our intake, deck side, and exhaust operations to the machine. So this is everything that we have to machine. What we do whenever we go to program this, we will come over and let's say I pick a exhaust for example. That will load, and you can come in, we tell it what our cut pattern is going to be, what surfaces we want to touch, and as you can see here, I have selected we are going to run this port. I tell it I want to do that. We'll end our selection. I will tell it how much of a machining offset we're going to have, that is how much stock we are going to leave on that surface, what kind of step over we're going to have, whether I want to output from the top side or the bottom side. Do I want to machine max from the top, max from the bottom, or do I want to give it a user-defined point to machine to? One of the things that really helps clean up your port is give it a overlap distance. That is saying as I machine forward, I actually overlap. And the big one is collision control. We don't use this on the exhaust faces, we'll use it on the deck faces. That is saying I don't want to touch any of that stuff. Because as most of you 5-axis guys know, clearance becomes clearance, Clarence, and if it doesn't have it, it will make it. So we don't want to make any clearance today. We want to tell it to avoid it. That comes with having proper machining geometry in there to know what to avoid, as well as proper tool and tool holder geometry to adequately and appropriately give this thing the clearance we need. So it is quite literally that simple. I can program an entire head in under 30 minutes. So all of the investment work is in front of the machine or on the port bench. That's all there is to it. It's not voodoo. So let's go over to the machine. We're going to get you in there. We're going to get some cool machining shots and hopefully not wreck anything. We'll find out. We're standing in front of the machine. I've got the cylinder head mounted in here in our super awesome CCA Racing LS LT small block Chevy 4400 bore space trunnion plate. Whew, that's a mouthful. So here's what we've got. You see here, this is the LT4. Got the big boy chamber wide open, ready for all of the boost, sitting in our trunnion fixture. So let's talk work coordinate. I have 4 work coordinates I utilize on this part. I have a work coordinate for the intake face, exhaust face, deck face, and CNC porting work coordinate. So all of these come off of one particular location on this trunnion plate, and that is the cylinder head dowel. So all of my work coordinates are based off of this hole. That makes it really easy. I can adjust as necessary as I'm running production on these heads. Gives me a little bit of sense of fine-tuning, especially since we are cleaning up every single face on this cylinder head. This head, once finished, will look brand spanking new. That's what we wanted whenever we decided we wanted to launch a late model cylinder head program. Whenever you take these off, the DIY guys that are doing it in production, there's no excuse to not ship somebody a part that's perfect. That's my take on it. I would rather take extra time to make sure that the product I'm giving out trumps anything else on the market. That's just what I want to be known for. So we are going to machine this cylinder head. So let's talk sequence. I start with ports first. We do all of the ports, intake and exhaust, and then we come back in. We skim all of the faces for a freshen up. That way we can refresh the sealing surfaces, intake, exhaust, and valve cover. That deburrs everything. It looks nice, shiny, and brand new. And we go ahead and we put our logo in it, because no part is complete without an insignia. We're proud of the name. We're proud of the part. You got to show a little bit of pride in your work. So I'm going to stick you in here. Let's run a cylinder head. Let's go. Well, all right, we've got a head out of the machine. It's sitting here on the bench. I just wanted to give a quick overview of what we've got, what kind of package this is going to be, what we're going to be offering, and of course showcase our CNC bility goodness that we're doing in the Haas UMC. So here we are. This is the LT4 package. You can see I didn't blast this head because this was a test head. So what you can expect from cylinder heads like this will get a full wet sandblast just to clean all of your exterior stuff up. The LT4 is a nice casting anyway. This is a A356 T6 casting material. And this is actually rotocast. That is a very fascinating manufacturing process. If you're kind of a nerd like me and like seeing how things are made, that is a really cool process as to how these things are made. I would highly advise you to check that out. It gives a really good surface finish. Supposedly makes a stronger, more dense casting, gets porosity out of it, so on and so forth. Now, I do know from personal experience on the LT heads, whether that be 1 or 4, you will see a little bit of core shift in the intake and exhaust ports. Not a lot, but the port is already very big anyway, so it is completely and teetotally okay to see shadowing from anybody's CNC program for these heads, just because this head was meant to be big, to move unabraded airflow into the cylinder to get air in under high pressure, since this is a direct injection engine. So we got some pretty good surface finishes out of this thing. Being that this is a A356 casting, of course it is going to be a nicer machining than the A319. A little bit higher silicon content, a little bit higher manganese content. Overall makes for a harder, durable material. Now, of course, that also comes at a higher cost, which is why you will see a lot of your really high production castings be a A319. It's just cheaper to make, and quite honestly, it's plenty good enough for what most people do. So you can see we clean up all of the faces of this: intake, exhaust, valve cover. I mean, the finishes on this thing are immaculate. Very nice. I like it. Of course, I'm the one that made it, so of course I'll be a little bit biased. So the next steps in this process is we have to take it to the SERDI. With this CNC program was sized and designed around reusing the OEM hardware. That is a 2126 15, I believe it's a 1590 exhaust valve. We just go in, we touch up the seats, make sure it blends very nicely in the chamber. It either gets shipped to the customer or we put it together and blueprint it here at Performance Driven Design. One of the two. We offer it both ways. Overall, I'm pleased. I mean, the thing is just phenomenal. This is what you need to expect out of CNC ports whenever you send them off to somebody. I know I personally am very nitpicky about anything that I get. I'm nitpicky about everything that I do. As a consumer, your money has bargaining power, and that bargaining power is, I had best get a very nice product. That's how I look at things. That's the type of stuff I want to be making, because I'm a consumer myself. I want to make sure I'm getting the best bang for my buck, and that's what we're trying to offer here. So this is it. This is basically what it is. You watched about roughly an hour and 15 minutes worth of CNC machining from the time we load this head in to the time we are ready to pull it out. I think that's everything I had planned. Well, to be quite honest, I think that's about everything I had planned for today. It's been a very productive day for me, at least. We've got some Oldsmobile heads running in the CNC right now. Got some LS1, LS2 castings valve jobbed. We are going to get this set of LT4 heads done tomorrow, slap them in the SERDI, go ahead and valve job them, and just validate that that port corroborates what we've seen with the LT1. And if it does, well, shoot, we have a tried and true proven CNC program. Thanks for watching. I appreciate you, and I'll see you next time.